All right. Okay. So let's start now on the real introduction to statistics, where we are going to discuss on different types of statistics or different branches of statistics. Okay. And before that, maybe we can do a recap of what we discussed yesterday. So yesterday we basically that is introduced different types of data in that is in statistics, and we saw that we have two major data types. Okay, that is uh, qualitative and quantitative. So we can classify type of data in statistics under two categories, qualitative and quantitative. And under each category, we saw we have that is further subcategories. Okay, like for example, and qualitative, we saw that we also have nominal and ordinal subcategories, and under quantitative uh, data types, we have what we call we have discrete. Okay, we have discrete and continuous, and we were able to differentiate that is each of the data type subcategory. Okay, yeah. So you will allow me to share maybe the notes today. If not today, I will share it tomorrow. Okay, once we've already discussed that is the introduction part. Okay. Yes. So for today, I want us now to do the real introduction to statistics. And here we are going to focus majorly on that is the branches of statistics. And I remember yesterday I told you that we won't go with theoretical statistics because we don't need that much theory under statistics, but it doesn't mean you can't go that is an extra mile and try to understand what is contained under theoretical statistics. Okay, you can always go do more research for your own knowledge. Okay, yeah, so that when you will be now creating models in machine learning, when maybe assuming like a certain property or a certain factor, okay, you know why you are doing that. Okay, yes. So majorly we are going to that is in this statistics class, we are going to focus more on applied statistics. Okay, and under applied statistics, it's further divided into some that into sub categories, that is descriptive and inferential. Okay, we have descriptive and inferential, but we shall go that is to those individual that is to individual subcategories and expound more. Okay, and expound more on the what, on those categories. All right, that's cool. Now I want us now to start with the definition, that is definition of statistics. And I know statistics it has the simplest definition. It has the simplest definition, and that is statistics can be confused by the definition of data analysis, because if you check, okay, how we are defining statistics and the data analysis definition, then you will what, you will find they almost have what, similar definition. Okay, so first of all, statistics, we know it is a branch of mathematics. Okay, we know it's a branch of mathematics dealing with with the collection analysis, interpretation, and presentation of masses of numerical data. Of course, it's like we have data and it is undergoing some processing. Okay, like for example, which is the major start point for statistics or for data analysis is data collection. Okay, data collection is the major start point of data analysis. Okay, so you do what? You collect. Then after collection, now you do analysis. We have very many different analysis depending with the structure of your data. Okay, now after doing the analysis, you can now do interpretations of your analysis, because if you have done analysis, okay, definitely you will get values. Okay, you will get values, and these values um, has no meaning unless now you interpret that is the analysis. Like for example, um, you might be a data analyst. I might be a digital marketing specialist. Okay, so I can't maybe I might find it hard to interpret your data. Okay, so you have to interpret, you have to make sense of what analysis you've made. Okay, that's why in that is in many companies, you will always give the interpretation part to your bosses, the interpretation and presentation part to your bosses. Bosses will need to see the graphs, the trends, to see maybe in terms of sales. How are we trending in terms of that is in terms of sales? Okay, so that's basically the interpretation, but they won't be interested much in on the analysis side, because the analysis side is your part. Okay, yeah. So we have collection, analysis, interpretation, and presentation. Now, presentation can be in very many that is format. Okay, you can present in terms of its visualizations, that is graphs. Okay, also you can create some short videos to present your findings. Okay, all right. So basically, I can summarize that is statistics and data analysis. They are likely they are more of the same thing. All right. Yes. Okay. I think we are good up to that point. Unless maybe we have question from you. From you before now, I can go to the next part. All right, we have now types of statistics. In case you find in case I'm fast, okay, in case I'm going fast, always feel free to tell me I'm going fast, because I know myself. Sometimes I might go fast. Okay, yeah, I'm used to. So in sometimes I might uh, go fast. So you can always unmute yourself and tell me you are going very fast, or in case you need a clarification. Okay. All right. Good. All right. Let's continue. All right. So let's continue. Okay, so we are going to start with the applied statistics. Under applied statistics, we have descriptive and inferential. Okay, and this we are going to start with descriptive, because descriptive is carrying that is the major part. Okay, of our class, and then we shall finish with inferential. And under inferential statistics, we'll only discuss more of that is we'll discuss more of hypothesis testing and also distributions. Okay. All right. Okay, let's now start with the descriptive statistics. And yesterday I gave you like a like an overview, or I gave you a short description of descriptive statistics. Okay, and under descriptive statistics, we said it from the term describe. Okay, it basically gives us a summary, or it describes more of our what, of our data set. Okay, yeah, that's why it is called descriptive statistics. So, descriptive statistics is a term given to the analysis of data that helps to describe. Yes, from the term describe. From the term describe. It helps us to describe. Okay, and shows summary of data in a meaningful way. So this is that is the important point here. It describes and summarizes that is a data set in a meaningful what? In a meaningful way. And we are saying that is the simple way to describe our data set, or to describe our data. So under descriptive statistics, uh, we are saying that it is very important to present our raw data in a meaningful way using numerical calculations or graphs or tables. This type of that is this type of statistics is applied on already known data. So for descriptive statistics, you can't do that is a summary of data set which you already don't have, okay, or which you don't have, but it must be of a known what data set. All right. Yes, and then we have types of descriptive statistics. I gave yesterday three. I can only see two here, but I will add the three. So the first one is the measure of central tendency. Okay, measure of central tendency. The second is the measure of variability. Okay, and then the third, okay, which is missing here, it is the measures of asymmetry. All right, yes, it is the measure of asymmetry. So let's start with the first one, measures of central tendency. Under measures of central tendency, we have mean, mode, and median. Okay. All right. Now, back to you, class, for your participation. Well, what is mean? How can you define mean? And here, when you are defining, make sure that is you use your term that is in the right manner, or you use your terms correctly. Let's start with the mean. What is mean? Someone? Question to the class. Oh, you mean you don't know the definition?
It's the average.
It is the average. Okay. I wouldn't object that. So, basically we can define mean as the simple average. Okay? It is the simple average. It is the simple average. Okay. Now let's go to the mod. What is mod? What is mod?
The most frequent number, I guess.
Huh? The most?
The, the most frequent number.
Where? In where?
Okay, in our data.
Yes. Yeah.
Yeah.
It is the most occurring. The most occurring data. That is value in a data set. Okay. And remember, mod can be a single mod or it can be multiple mod. Is that correct?
Yeah.
Yes, let's take an example. Let's say we have one, okay, we have two, we have three, we have one, we have four. So what is our mod here?
One.
It is one, okay,
Yeah. Mm.
good. Then we have two, we have six, we have five, we have four, we have five. What is our mod here?
There are two. Can they be two?
Yes, of course, here we will have a set of two mods. That is
Oh, okay, 2 and 5.
2 and 5. So this is multiple mod and this is single mod. Okay?
Okay. Okay.
All right. Now, let's go to definition of median. And whoever is that is
Clear.
okay. What is the definition of median?
Median, we said, is the average.
Median,
Oh
not
no,
mean.
median.
Mm,
Okay. Median. I'm not sure.
okay. Someone else?
I think median is the value in the middle of a data set or an average if they are two.
Hmm, close, but if I was to give you a mark, I could give you a 0. There is a very important statement or point you've left. Someone else. Someone else? What is median? Yes, please.
Median, I think, is the middle number in a data set when arranged from the in ascending order.
Very correct. Not it's not a must to be in ascending order, but
Yeah.
the arrangement is very important. Okay, so we should say that is median is the middle value in an ordered list or in an ordered set of data. Okay, so there must be order, there must be arrangement, either in what? In an ascending order or in a descending what? In a descending order. You have to arrange first for you to know the what? The median. Okay. Otherwise, the two that is the two answers were correct, but the second we can say it is more accurate, okay, because we must order, there must be that is an order of our list of values. Otherwise that was good. All right, now let's go to the next slide. Imagine we've summarized almost how many slides? 1 2 3. We've already completed three what? Three slides, because The other thing, it's what? It's only the practical part of it. Okay. All right. So let's start with the with this one. So descriptive statistics, you can see. Um, Descriptive, it's divided into two categories: measures of central tendency, measures of variability, and also we have measures of asymmetry. So we under measures of central tendency, we've discussed mean, mode, and median. Okay, under measures of variability, we'll discuss that is on range, in fact variance, and what, standard deviation. Please ignore this one. Okay. So under central tendency, so an essential concept is the measure of central tendency. This measure is important way to summarize the way our data set is what is represented, or I don't want to say distributed, because when I say distributed, we will now be talking about variance. Okay, but we can say that this measure is important as it summarizes the whole data set with one value. Okay, and present it with one value. Like for example, if you do a mean, you will get what, a one value. If you do that is mode, but mode you might get more. If you do median, you will also get one value. Okay, you will calculate and get one value. That's it. Okay, good. Now this measure provides that is a rough picture of where data points are centered. The commonly used measures of central tendency are mean, median, and mode. Okay. All right. Let's now check to mean. So we say that mean is average. Yeah, it's the symbol average, meaning for us to get mean. Okay. So let's say we have these values. Let's say x1, x2, x3, x4. You can even go up to xn. All right. So these are what? These are our x values. Okay. They are the xi's. Okay. Whereby I is taking 1, 2, 3 up to n. It's the same thing we've presented here. Okay, meaning now this will be x1, x2, x3, x4. Okay, it can you can go up to xn. Okay, so these are we can call these, they are our observations. Okay, we can say they are our observations. So we can calculate mean, and we know that mean, that is x bar, we usually in fact, before I can come here, remember we have different that is measures, or we have two categories, okay, of data sets. We have population data, population data, and then we have sample data. What do you understand by the term sample data or population? Can someone differentiate between population data and sample data before we can even now talk about mean? Because I will need us to define some things. Someone that is.
Okay, I do not know the definition, but I'll give just with an example. Our population data is like yesterday when you were asking how many people know about statistics, then you no, let me start with sample. Then you said you wanted at least 10 people. for you to get a understanding of the how people know statistics. So that was a sample data because the entire population is like 18. Then the population data is when you would have asked an opinion of the whole 18 people.
Okay, so like population, it's like we are talking about the whole team or the whole values under study. Like for example, yes, like for example, let's say uh, you are sent to collect data from a certain village. Okay, let's assume that village, let's call it village Q. It has that is all the population, or it contains a population of 6,000 people. We have in that village we have 6,000 people. Okay, so this is the what? This is the population. The total values, okay, all the let me just say the total values in that is in study. Okay, then we have sample. Of course it will be tedious, okay, it will be tedious to go and maybe interview all these 6,000 people. It might be very hard to. Okay, so you can decide to take a portion, okay, or to take some few people from this population so that you may interview them to get maybe the data you need about that is about the population. So you might take that is or you might interview 500 people. So 500 people will be what? A sample size, okay, or will be like a sample data which will explain about what? About the population, okay, it will explain about the population. Good. Now I hope that is clear. We have now the population, it's the whole or the whole data set which you are trying to study, or the whole population which you are trying to study. Then we have sample, whereby it is a portion of the population. And for population, we have mean for the population. Mean for population is always denoted by mu, by this some simple, okay, this sample it is called mu. Okay, I usually write it this way, it is called mu. Then we have, this is for population, mean for population. And then we have sample mean, we have sample mean. Let's say this is population mean, population mean. Then we have sample mean. For sample mean now, mean is the that is represented or denoted by x bar. Okay, mean is denoted by x bar. I hope that is clear. So now we can come to our that is calculation of our what? Of our that is of our mean. Again, we also have something we call sample size or size. That is the sample size of a population. Let's say it is, we have sample size and we have population size. This is like the observations, you have the total observations. So for population, okay, for population size, we denote it with capital N. So which is this one, like 600. 600 sorry, 6,000 is the total number of people to be interviewed. So the size, this N is the size to be maybe interviewed, or the size of our data. Then we have sample sample size, it is denoted by N. And now here our sample size here, it is what? 500. Take note of that. So I'm going to give an example. Let's assume we have these values. Okay, let's start with this. So let's say we have x1, x2, x3, and x4. Okay, we want the mean of this. Okay, so what are we going to do? Of course, we want the x bar. X bar is the sample mean. Okay, and this is sample because we are talking of only 4 people. Okay, or 4 values. So it will be equal to also expectation of x. Expectation of x, it's also mean. Okay, those who did advanced applied statistics, expectation of x, that is x bar is equal to expectation of x. If you can, we have a way to derive this. We usually have a way to derive this. Okay, but I won't do it here. Okay, let's now continue. So here our mean or our sample mean will be x1 plus x2 plus x3 plus x4. And what is our sample size? Can someone tell me the sample size? What are we going to divide with here? What is our sample
4.
size?
4.
Yes, n is equals to 4 because we only have 4 values. Okay, so it will be divided by 4, and basically this is the mean. Okay, this is the mean. And in Excel, we shall also do some practicals, but my practicals I usually use Excel because you will also use Python while on the same. Okay, while you will be studying machine learning. So we have, that is the formula for mean in Excel. It is average. It is average. Okay, so this is the function in what? In Excel. Then we have mod. So in mod we have what? We have 2 functions. Okay, we have single mod, and multiple mod. Don't worry about my handwriting. So we had discussed about the mod here. So I don't have much to explain under mod. Now let's go to median. Under median, we say that median is the what? The middle value of an ordered list. But it is not always the case. Why? Because median depends with the what? With the number of that is the number of values. The total number of values might all the number of values might be even, or it might be odd. Okay, when it is even, you will take the 2 middle values, add them, divide by 2. Okay, then if that is your data set as an odd sample size, okay, then you'll definitely take the most middle value. Okay, you will take the most middle value. Like for example, let's say we have 2, we have 6, we have 7, we have 5, we have 3, we have 4, we have 1, we have 2. So what is the median of this data set? Can someone tell us the median of this data set? What is the median of this data set? No. It's okay. Okay, maybe I want to change something so that I may start with the simplest one. Yes, tell me, what is the median of this value of this data set? Just a minute. What is the median of this data set? We have 2, 6, 7, 1, 3, 4, 5.
4.
Okay, someone has said 4. Another person. Another person.
4.
Oh,
Okay, seems you are all saying 4. So let's try and see. So we have first of all to order either in ascending or descending order, whichever way you like. So we have 1, 2, 3, 4, 5, 6, 7, and this is what it is an odd. Okay, we have an odd count, like we have 1, 2, 3, 4, 5, 6, 7. That is 7 is odd. Okay, yes. So we are going to just take the most middle value. So we have 3 here, we have 3 values here, and we have 3 values here. So 4 is the middle. It is the middle value. All right. What about if I were to remove maybe 7, or if I were to remove 3? What would be our median?
Four 4.5.
4 point?
4.5. 4.5.
Let's check that. So we have 1, 2, 4, 5, 6, 7. So of course we have 1, 2, 3, 4, 5, 6. We have 6 values, and this is an even number, right? So it will be, we'll take the 2 middle values, add them, and divide by 2. So it will be 4 plus 5 divided by 2, which will be 9 divided by 2, which is 4.5. Correct. Yeah, this is correct. I hope we are now good with those 3 measures of central tendency. We are all good. All right. So just to go through the slides. So like average value is termed as the mean of data set. It is very easy to calculate mean. But before I can continue, we usually have one big drawback of the mean, of using mean, which is the most drawback, or which is the disadvantage of mean. What is the disadvantage of mean, or of using mean to conclude about that is a data set? Yes. What is the major drawback? It's very simple. Yes.
I think mean cannot be used in nominal data. in categorical data.
Okay, okay, it's a good point, but that's not the point I want.
Let me give a try.
Mm-hmm.
Yeah, in some data sets,
Mm-hmm.
it may not be a true representation, especially if we have extremes
Good.
in terms of what we call outliers.
Yes, that's the point I needed. Mean is highly affected by outliers. That is, and outliers, remember, they are extreme high or small values. It can be extreme high or extreme low. Like for example, if we had these values like we have, and that is 1,000. Okay, we have 2,000, we have 1,500, we have 3,000, and we have 10. So you can see this value. When we calculate mean, it will bring the mean that is too low, meaning it will affect our mean. What about if this was maybe 100,000? Of course, it will also affect what? It will affect our mean and tend to go up. Okay, our mean will tend to go up. All right, good. Okay, now we can now continue with our slides. So basically, we can these are the steps to calculate mean for those who maybe might need a recap on the same. We have count the number of the values, let it be n. We've said n is our what? Sample size. Then add all the values and that is let the sum be s, that is the sum of all that is all the values. Then the mean will be given the sum of all values, that is s, divided by the total number of the data values, that is s divided by n. Basically, that's the mean. Then we have the median. So the median is the middle value of the sorted, that is sorted data set. Yeah, of a sorted data set. Okay. Yeah, and you can sort it in a ascending or descending order. Okay. Yeah, and it's called median. So let's now see how we can calculate. So let's assume we have n elements in our data set. The step one is to arrange in either increasing or decreasing order. Then the second step is the data set as an odd if the data set has an odd number of data values, that is n is odd, then middle most value of the sorted data set is computed as what? As the median. But if it is even, then you will have to take the two middle values and divide by 2. Right? So if the data set has an even number of data values, that is n is even, of course I have discussed that. Cool. What about mod? We've said that mod is the most frequently occurring value in the data set. It is called mod. Okay. Yes. So for this, use tally marks to identify how many times each data value occur in a data set. The data value with maximum tally is the mod. Then we have some examples here. I won't do the examples because they are the same thing. Then we have some disadvantages of what? Disadvantages of mean. That is, mean is highly impacted or is highly affected by extreme values in the data set. Okay. Yes. So then after that, of course, will come now. This will come later. This will come later. In fact, this will be this should be, you can see the measures of that is symmetric distribution, or measures of asymmetry. We shall talk about now the skewness. That is the positive skewness, zero skewness, negative skewness. Okay. Yes, and also the kurtosis. And kurtosis basically tries to show us that is how that is, or how our data is distributed compared to a normal distribution. If it has a long tail, okay, that is if it has a fat or a thin tail. Mostly we'll discuss that when we'll be doing distributions, okay, about the fatness and the thinness of the tail. And I think the tail is basically just to show you, like in a distribution, let's say this is the normal distribution. This is the tail. So the tail, we usually check the thickness, then thinness of this tail. Okay, like for example, you can see this is thin compared to this. You can see the tail, it's this one, it's thin compared to this, and we have some factors which contribute to this. All right. Now, the best measure of central tendency. So mean is preferred measure of central tendency when data is normally distributed. Median is the best measure of central tendency when data is skewed. While dealing with nominal variables, the model is the best measure of central tendency. But we usually say, if we want to make conclusions, don't rely on mean only. Please rely on the what? Rely on all the all the measures of central tendency to make that is your decisions. So we have a conclusion and measures of central tendency. That is mean, median, and mode are the most important of measures of central tendency. It is not necessary for mean, median to have the same values. Mean is sensitive to extreme values, and it is not wise to take the mean of skewed distribution as the true mean. Okay, it is not good to take the mean of a skewed distribution as the true mean, okay, or as a true representative of the data set. Yeah, so you can then mean and median can never be zero, or cannot be zero unless all the data values are zero. If you get a mean or a median of zero, then no, there is a problem with what? With your computation. Now, good. Let's now go to measures of variability. Otherwise, before we can start on the measures of variability, I'm going to give a room for questions. You can ask questions. Okay, you can ask questions.
Good evening.
Good evening.
Maybe you can repeat on that central tendency thing, the purpose of it. I think I missed it. That part, I think I might have missed.
The whole thing, or the measures
No,
of
not the measure, not the mode, median, and what the purpose, or what's the reason why we are getting all this? What's the, as far as the analytics point of view is concerned?
Okay, so basically, we had said that these measures of central tendency basically gives us a summary of our data set into one value. Okay, like for example, if we compute let's say a mean, okay, like, and get a mean of 40, then it means most of our data points, okay, are revolving around what, around the mean. Okay, and you will see that we have a connection between variance and mean. Why? Because variance now tries to study how the data sets are spread away from the mean. Okay, but for measures of central tendency, it basically summarizes the whole data set to a one value. Okay, like you can try to check let's start with like range. Okay, you can try to check like most of our data, how is our data distributed. Like if we get a mean of 1,000, then it means most of our data points are what, are revolving around 1,000, plus or minus some few value, that is some few maybe figures. Okay, around what, around the value of mean. So basically that's the major use of measures of central tendency, to summarize the whole data set to a one value. Okay, for us to get those simple insights about what, about the mean. Like for example, if we are talking about the age, okay, in a class. So let's go to class 1. Okay, let's even take class 8 and say that the average age of all class 8 students, it's 11 years. Okay, this will mean most of the what, most of the students in that class, that is their age revolves around what, 11, 12, 10 years. Okay, so you can be able to know that is the distribution of your data set. Okay, when we talk about the middle, okay, you know that is and you can bear with me when calculating mean and median. They usually that is their values are usually close to each other. Okay, that is their values are almost close to each other. Why? Because for this is showing us the central what, the central value. If they are close to together, then you can conclude and say that your data set, okay, has no much that is variance, or has no much difference between its data points. Okay, that's the conclusion we can make, and then with that you can say that is your data, it's good to do what, to work with. Okay, but what about if most of your data points are ranging between 10 and 20, and find that your mean, it is what, it is 100. Okay, so that means there is a presence of an outlier. So with that you will be able to go and that is try and check what is affecting your mean. If you find it's an outlier, then you will have to do what, you have to plug it out, because that's the only way to sort that is the outlier issues. You have to do what, you have to remove it. Yes, you have to remove it. I hope I was clear on that.
Yeah, yes.
Okay.
Thank you.
Any other question or comment or an addition? All right. Thank you. I think you've understood well. Okay. So now let's go to measures of variability. And under measures of variability, under measures of variability here, we'll talk about variance. We'll also talk about standard deviation, and we'll also talk about covariance. Okay, so let's start with variance. What do you understand by the term variance? What do you understand by the term variance? Someone? Someone? Okay, someone to define variance. Someone? Yes? Yes, please, you can unmute.
Let me try.
Okay.
Variance is the how is okay, the difference in your data set.
The difference in your data set. Yeah. There is, I can say you are so close. You are so close. Okay. But not correct. Very close. Because you've said it's difference between your but we can usually say it is difference, that is difference between your data points to the mean. Because how do you do it? Like we usually say, it is x maybe I minus the mean, okay, squared. This squaring is just to make sure we get an absolute value, that is a positive value. Okay, because sometimes you might get a negative. Okay, sometimes you might take this and minus this, get a negative. So in that, you will have to square to change it to what? To also a positive. But we usually say we have what? It's like we are squaring the difference. So we can say that variance shows us how our data is spread away from the mean, how our data points are spread away from the mean. Basically, that's the definition of variance. Why? Because you can say, let's assume this, it's what? This is mean. So, and we have our data points here. Okay. So, the distance, the squared distance, it is what? It is our variance. Yes. And then we also have standard deviation. And under standard deviation, it's basically the square root of what? The square root of that is of variance. And it really helps us when it comes to that is when you are investing. It helps you to that is to know which maybe portfolio is more risky, okay, or which stocks are risk to invest. All right, so let's try and see what the slides are telling us. I just want to go through only these two slides. Let's say yeah, let's say these two slides, and then we'll call it a day. Then tomorrow we shall start under what? and the standard deviation. So let me go through these slides and then we can call it a day. So key takeaways, no, sorry, let's start here. So what is variance? So the term variance refers to that is a statistical measurement of spread between the numbers in a data set. Okay, the spread between the numbers in a data set. More specifically, variance measures how far each number in the set is from the what? From the mean. So we are trying to check like the spread, how our data set is spread away from the what? From the mean. And that's for every other number in the what? In the set. So variance is often depicted by a simple sigma squared. Yes, now let's come to about the population and the sum, that is the sample thing. Okay, so for a population variance we usually denote it with what? With a sigma square. Okay, or yeah, sigma square. And then for sample we usually that is use this symbol s squared. So this is the variance for um sample standard, sample variance, and this is for population variance. So for population now, standard deviation, it will be now sigma, and this will be s. That is because we'll do a square root of each for us to get what? The standard deviation. Okay, good. Okay, it is used now. Variance. Where can we use variance? Variance is used by both analysts and traders to determine volatility of market securities. Okay, so this is majorly used to show us the volatility, because the higher the variance, it means our market or our securities are very volatile. What do we mean by volatility? Volatility might have a positive impact, and also it might have a negative impact. Like for example, if you had bought shares at what? 12 shillings. Okay, each share. Okay, and you bought 10 shares, meaning you bought all your 10 shares that is at 120 shillings. Okay, then the market, due to certain factors, the price of the shares might what? Might fluctuate. It might hike. Okay, to a very high price. Like for example, it might hike from 12 shillings to 100 shillings. Meaning, if you had 10 shares, you will now have what? 10? That is 1,000 in that is amount that you can earn. So with that, you can sell. Okay, but let's assume the share price now went down to 0. What? 0.1, depending with what? Depending with the market. So of course here you will enjoy your losses as you enjoyed the profits. You might have enjoyed the profit. So here you will have losses, and here you will have profits. Okay, now the rate of change, okay, or the variance, is now what? That is the difference. It is not now in prices, it is now what we are calling what? We are calling variance. Okay, so if, like for example, here we had like a variance of 82, of 88 shillings. Okay, so you can see volatility was very high. Okay, though into a positive maybe impact. Okay, yeah, so that's how we usually use that is the knowledge of variance to know where to invest or to know which securities to invest in. Okay, so majorly the higher the variance value, the high volatility. Okay, the low the variance, the low the volatility of your securities. Then we have the square root of variance is the standard deviation, which help us to determine the consistency of an investment return over a period of time. So with this, it gives us the consistency of maybe prices, like in terms of an investment, how has this investment returned, okay, for the last maybe few years. Okay, yes, so maybe some takeaways. Variance is a measurement of the spread between numbers in the data set. Investors use variance to see how much risk an investment carries and whether it will be profitable or it might have some losses. So variance is also used to compare the relative performance of each asset in a portfolio to achieve the best asset allocation. And in statistics, we usually take that variance measurements or variability from the average. It is calculated by taking the difference between each number in in the data set and the mean. So I want us now to that is to write a formula out of that. So it takes the difference. So let's say we have some values x i's where that is where I is equals to 1, 2, 3 up to maybe n. Okay, so here we are saying that it is given by x i's minus what? The x bar, because we only have one mean. So this it's one point. Okay. Then squaring the difference to make them positive or to make it absolute. We are squaring all the values, differences to make them positive. So we square here to make them positive. Then and finally dividing the sum of the squares by the number of values in the data set. So let's assume we have n observable values. So these are our values. So it will be, we will divide now the summation of all these by what? By n. So with that, we'll have to add summation sign from I, okay, from I to what? To n, I starting from 1. Okay, then divide by n. So we can say this is now the variance, the sample variance. So this is the formula for sample variance from what? From this statement. And that now marks the end of our today's class. And I do now welcome questions or uh, questions or that is additional comments on this before we can conclude the class. Now back to you.